A quadratic form is one of those objects that looks like a formula, behaves like geometry, and then quietly runs half of linear algebra from the basement. Given a real square matrix A, the expression Q of x equals x transpose AX is called a quadratic form. It takes a vector and returns a scalar. The word quadratic means every term has total degree 2. Not that someone wanted another word to memorize. In two variables, a symmetric matrix gives the usual quadratic expression with one square term, one cross term, and another square term. The off-diagonal entry contributes once from the upper right and once from the lower left. That is where the factor 2 comes from. Astonishingly, bookkeeping matters. Even if we start with a non-symmetric matrix B, the quadratic form only sees its symmetric part. The skew-symmetric part K satisfies K transpose equals negative K. But X transpose Kx is a 1-by-1 scalar, so it equals its own transpose. Therefore X transpose Kx is equal to its own negative, so it must be 0. The skew part disappears. It had one job, and even that was imaginary. For a real symmetric matrix A, the spectral theorem gives an orthonormal eigenbasis. In matrix language, A equals Q lambda Q transpose. If we write the same vector in that eigenbasis, using Y equals Q transpose X, the quadratic form becomes diagonal. All cross terms vanish. The form becomes a sum of eigenvalues times squared coordinates. This is the part where the matrix stops mumbling and tells us what it is doing. Once the form is diagonal, its behavior is decided by the signs of the eigenvalues. Positive eigenvalues make every non-zero vector give a positive value. A mix of positive and negative eigenvalues means the form can output both signs. Such drama, from just changing direction. Level sets give a fast visual check. Positive definite forms make ellipse-shaped level sets around the origin. Indefinite forms make hyperbola-shaped level sets. Because some directions increase the value and other directions decrease it, the form cannot make up its mind. Quadratic forms are the language behind positive definite matrices, induced norms, conic sections, and second derivative tests. Somehow one expression keeps showing up. Very suspicious. The main idea is simple. A symmetric matrix defines a degree 2 scalar function, and the spectral theorem tells us exactly what shape that function has.